Our sun, a giant ball of burning gas, is not always calm and steady. It is a dynamic and ever-changing star. It throws tantrums, bursts of energy that we call solar flares. These flares are sudden and intense. Imagine the biggest explosion you can and then multiply it by 1,000,000. The sheer magnitude is almost unimaginable. That's the power of a solar flare. These eruptions can release as much energy as billions of atomic bombs. These flares are like sudden bright flashes of light. They can light up the sun's surface in an instant. They release huge amounts of energy traveling at incredible speeds. These particles can reach Earth in just a few days. These energetic outbursts are not just fascinating to watch. They are a testament to the sun's immense power and activity. They can affect us here on Earth, even though we are millions of miles away. Solar flares can disrupt our communications and power grids. Solar flares are a reminder of the sun's power and our place within its reach. They show us how interconnected we are with our star. Understanding them helps us prepare for the potential impacts they might have on our planet. Scientists study these flares to predict their effects. As we delve deeper into the world of solar flares, we'll uncover the science behind these cosmic events and their connection to our home planet. The more we learn, the better we can protect our technology and infrastructure. From the beautiful aurora borealis to potential disruptions to our technology, solar flares have a wide range of effects. The story of solar flares is a captivating blend of science and wonder. It is a tale of cosmic forces and their impact on our daily lives. So buckle up as we embark on this journey of exploration, unraveling the mysteries of our dynamic sun. Together we'll discover the secrets of solar flares and their profound influence on our world. Deep within the sun, a constant dance of charged particles creates a powerful magnetic field. This field is like a giant invisible web, twisting and turning within the sun's fiery core. Think of it like a rubber band. As the sun's magnetic field lines twist and tangle, they build up enormous amounts of energy. When these tangled lines suddenly snap and reconnect, a tremendous amount of energy is released in a solar flare. These flares erupt from the sun's surface, sending waves of radiation and charged particles out into space. It's like a cosmic sneeze, a sudden expulsion of energy that can be felt across the solar system. But these sneezes are not to be taken lightly. They pack a punch, carrying the potential to disrupt our satellites and even our power grids here on Earth. Once a solar flare erupts, it sends a wave of energy and charged particles, known as a coronal mass ejection, CME, hurtling through space. These solar flares are massive bursts of radiation that can release as much energy as billions of atomic bombs. If Earth happens to be in the path of this CME, these particles can interact with our planet's magnetic field. The magnetic field acts as a protective barrier, but it can only do so much against the sheer force of these solar events. It's like a cosmic game of billiards, with the Earth caught in the crossfire. The particles ricochet off the magnetic field, creating a spectacular display of energy. The Earth's magnetic field acts like a shield, deflecting most of these charged particles. This deflection is crucial in protecting our planet from the full brunt of the solar storm. However, some of them manage to penetrate our defenses, entering the Earth's atmosphere near the poles. This penetration can lead to various atmospheric phenomena and disruptions. As these particles collide with atoms in our atmosphere, they create a dazzling light show known as the aurora borealis, northern lights, and aurora australis, southern lights. These lights are not just beautiful, they are a visible reminder of the powerful forces at play in our solar system. While the aurorae are a beautiful consequence of solar flares, the impact of these events can be more than just a light show. They serve as a warning of the potential dangers that solar activity can pose to our technology and infrastructure. The charged particles from solar flares can disrupt satellite communications, interfere with GPS signals, and even cause power outages. These disruptions highlight the need for continued research and preparedness to mitigate the effects of solar storms on our modern world. Imagine standing under a sky ablaze with vibrant colors, shimmering curtains of green, blue, and red dancing across the horizon. This isn't science fiction. This is the aurora borealis, a breathtaking spectacle caused by solar flares. When charged particles from the sun collide with oxygen and nitrogen in Earth's upper atmosphere, they excite these atoms, causing them to release energy in the form of light. This light creates the mesmerizing display of the aurorae, a reminder of the sun's powerful influence on our planet, even from millions of miles away. The colors of the aurora depend on the type of atom being excited, and the altitude at which the collisions occur. Green, the most common color, is produced by oxygen at lower altitudes, while red, a rarer sight, occurs when oxygen is excited at higher altitudes. Nitrogen can produce blue and purple hues, adding to the aurora's ethereal beauty. Section 5. The 1859 Carrington Event, a solar storm for the history books. In 1859, the world witnessed the most powerful solar storm in recorded history, the Carrington Event. This monumental event was unlike anything seen before, and its effects were felt across the globe. Named after British astronomer Richard Carrington, who observed the solar flare that triggered it, this event serves as a stark reminder of the sun's potential to disrupt our lives. Carrington's meticulous observations provided invaluable insights into solar activity. The Carrington event caused telegraph systems worldwide to fail, with some systems even catching fire. Telegraph operators reported receiving electric shocks and telegraph paper spontaneously ignited. The aurora borealis was visible as far south as the Caribbean, a testament to the storm's intensity. People in tropical regions were astonished to see the night sky lit up with vibrant colors. Imagine a world without electricity, communication systems down, and the night sky illuminated by an ethereal glow. The sheer magnitude of the event left people in awe and fear. That was the reality during the Carrington event. The skies were ablaze with light, and the world was plunged into a temporary state of chaos. This event serves as a crucial reminder of our planet's vulnerability to powerful space weather events. It underscores the need for modern society to be prepared for such occurrences. While such extreme events are rare, they highlight the importance of understanding and preparing for the sun's unpredictable nature. Advances in technology and science have made it possible to monitor solar activity more closely, but the threat remains ever present. Section 6. Disruptions from the sky: how technology feels the heat. In our increasingly technology-dependent world, the impacts of solar flares become even more significant. Satellites, the backbone of our communication and navigation systems, are particularly vulnerable to the onslaught of charged particles from CMEs. Imagine losing GPS navigation, satellite TV, or even mobile phone service, all possible consequences of a powerful solar storm. Furthermore, power grids, essential for modern life, are also at risk. The fluctuating magnetic fields caused by CMEs can induce currents in power lines, potentially leading to widespread blackouts. The 1989 Quebec blackout, which left millions without power for hours, serves as a stark reminder of this vulnerability. As we become more reliant on technology, understanding and mitigating the risks posed by solar flares becomes increasingly critical. Space weather forecasting and developing resilient infrastructure are crucial steps in safeguarding our technological world from the sun's unpredictable outbursts. Section 7. Space weather forecasting: predicting the sun's next move. Just like meteorologists predict weather patterns on Earth, space weather forecasters monitor the sun's activity to predict solar flares and CMEs. Using a fleet of spacecraft and ground-based observatories, scientists track sunspots, solar flares, and CMEs, aiming to provide timely warnings of potential impacts. These forecasts are crucial for protecting our technology and astronauts in space. They allow satellite operators to take protective measures, power grid managers to prepare for potential surges, and space agencies to adjust mission plans to minimize risks to astronauts. Space weather forecasting is still a developing field, but it plays a vital role in mitigating the impacts of solar flares on our technologically dependent world. Section 8. The future of solar physics: unraveling the sun's mysteries. Despite centuries of study, the sun continues to hold many mysteries. Scientists are constantly working to improve our understanding of solar flares and their impacts on Earth. Advanced telescopes, both on the ground and in space, provide increasingly detailed views of the sun, allowing scientists to study these powerful events in unprecedented detail. By unraveling the complexities of solar physics, we can develop more accurate space weather forecasts, design more resilient spacecraft and power grids, and ultimately learn to live in harmony with our energetic star. The quest to understand the sun is a journey of discovery, pushing the boundaries of science and technology, and ultimately benefiting humanity. Section 9. Conclusion: living with our energetic star. The sun, the giver of life, is also a source of powerful and potentially disruptive events. Solar flares, those bursts of energy from our nearest star, remind us of the delicate balance we strike as we venture further into the cosmos. By understanding the science behind these events, we can take steps to protect our technology, safeguard our astronauts, and ensure a future where we can harness the sun's energy while mitigating its potential risks. As we continue to explore the universe and unlock its secrets, one thing is certain: our relationship with the sun, our nearest star, will continue to shape our destiny. By studying the sun, its flares, and its influence on our planet, we gain a deeper appreciation for the interconnectedness of the cosmos and our place within its grand tapestry.